Good morning, students. The topic is QADT. So, like stack, Q is also a linear data structure. Okay, why it is called as linear data structure? Because the elements are stored in sequential order. Here we follow the principle first in, first out. So, which means that the item which is inserted first is going to be deleted first. So, that's why it's called as first in, first out principle. You can perform the addition operation and the deletion operation with the queue by using two different positions. For example, the insertion operation is performed at rear end position and the deletion operation is performed at front position. So this is a real life example for queue data structure, one-way LAN. So here some cars are standing. So the car which is standing in the front position is going to be moved first. So this is called as first in, first out. Some other examples for queue data structures are queues at the ticket windows and queues at the bus stops. Once again, queue is a linear data structure. Here the insertion operation is named as NQ and deletion operation is named as DQ. For insertion, we are using the position rear end, and for deletion, we are using the position front end. Like stack, queue can also be implemented with the help of two ways. One is by using array, the other one is by using the linked list. So this is an real life example, one more real life example for queue insertion and deletion. So see, in the ticket counter, several persons are waiting in the queue. Whenever the new person is coming, he is entering into the queue at the rear end position. Who gets the ticket first? The person who is standing in front position. So he will get the ticket first. So this is what happening in queue insertion and deletion. So if I want to insert some value into the stack, I can use the function NQ. So NQ is a function which is used to insert a new element into the stack. Always the new element is inserted at the rear position. So for insertion, you have to give one integer value as the parameter, and that integer value is inserted into the queue. So the steps for insertion, first we have to check whether the queue is full or not. You can check for full queue with the condition rear equal to size minus 1. So here the size indicates the maximum array size, that is the queue size. Once again, why I have given here it as size minus 1 means because the index starts from 0. We assume that the index starts from 0. That's why we are given like that. So if rear equal to size minus 1, if rear equal to size minus 1, it indicates that queue is a full queue. So you cannot insert one more element into the queue. So you have to give the error message, insertion is not possible, and you can terminate the function. If the queue is not full, then you can perform the insertion operation. To perform the insertion, you have to increment the rear pointer. Then you can use that empty slot, that is queue of rear, to store the value, to store the new value. So this is what happening in insertion. So see the diagram. We have the elements 10, 20, 30 in the queue. I want to insert 40. First I have to increment the rear pointer by 1, and we can use that empty slot to store the value 40. Similarly, if I want to delete the element from the queue, then I have to use the function DQ. Always the element from the front position is deleted first. For the DQ function, you don't need to give any parameter. The steps are, first we have to check for the empty queue. So how can we check with the empty queue? If friend equal to rear, it indicates that it is an empty queue. So you cannot perform the deletion operation. Okay. If the queue is not empty, then you can perform the deletion function. So to delete the element, you have to increment the friend value by 1. Then you can display the deleted element by using the statement queue of friend. Okay. So for example, see the diagram. So we have the elements 10, 20 and 30 in the queue. I told always the element at the front end is deleted first. So 10 is deleted. After deletion, okay, you can increment the friend pointer by 1. Okay, you can increment the friend pointer by 1 and the deleted item is displayed. After the deletion, okay, you have to check whether both front and rear are equal. If it is true, then you have to set both front and rear to -1. Okay, so that's about deletion. If we want to display the elements of the queue, then as like as the stack, here also you can go with any loop. Okay, by moving the pointers, by moving the index, you can display each and every element of the queue. Okay. So if the queue is implemented using linked list, then how can we perform the insertion and deletion operation? So what is the problem of array implementation of queue means? Once again, as like a stack, here also we have to specify the size in advance and it is working with only fixed number of data. So to overcome this, we go for linked list data structure. Okay, here also the new node is always pointed by the rear end and the first node is always pointed by front pointer. Okay, so this is the figure. So we have several nodes 10, 15, 22, 50. They are the elements and each node consists of two parts, data value and the next part. So the next part contains the next node address. The newly inserted node is pointed by rear and the first element, first node is pointed by the pointer front. For insertion, you have to create the new node and you have to set the next part of new node as null. Then we have to check whether the queue is empty or not. If rear equal to null, it implies that it is an empty queue. So this is the first element we are going to insert. So if the queue is empty, then you have to set the front as new node as well as the rear as new node because we have only one node. So both front and rear pointer points to that single node. If it is not empty, then you have to set the rear of next as new node. Okay, if the queue is not empty, we are going to insert the new node 26 after 45. I told always the insertion taken place at the rear end. Okay, to perform the insertion, you have to set the next of rear as new node. Okay, so that is rear of next is equal to new node. After the insertion of new node, the new node becomes the rear end. Okay, because always the rear points to the item which is inserted last. So the last node is 26. So it is pointed by rear end. So what is dequeue function? So dequeue function is used to delete an element from the queue. To delete an element, first we have to check whether the queue is empty or not. If front equal to null, it indicates that queue is empty because the deletion taken place at the front end. Okay. So if it is empty, then you have to display queue is empty error message and deletion is not possible and you can terminate from the function. If it is not empty, then you have to define one temporary pointer. That temporary node pointer is set to friend. Okay, so you can free the temporary node, and after deletion the friend is moved to the next node. So like that. So we have the nodes 12, 45, 26. So 26 is the last inserted node, so it is pointed by the pointer here, and 12 is inserted at first, so it is pointed by friend end. So always the deletion taken place at the friend end. So 12 is the node we are going to delete. So it is assigned with one temporary pointer, and after deleting the node, the friend should be points to the next node, that is friend is equal to friend of next. Now friend points to 45, that is the next node of 12. Okay. For displaying the elements of the queue, okay, you can go with any loop, and you have to start from one end, and you can print the data. After printing the node value, it is moved to, we are moving to the next node. So this process is repeated until the next part of the node becomes null. Okay. So thus we are displaying the elements of the stack. So that's about the QADT. Thank you all.